we're going to be using it if it's a smaller valley than this one. So it'll be still around.
Well, I was talking to Derek the other day. Should I start with the operator? Should I cut down? You know, those inversions and stuff.
Okay.
For right now, he said.
Time on it.
Almost there.
Yeah, no, it's had more time on it for sure. I don't feel bad about that at all.
You, sir? Yeah, no. Good.
It's having something. Yeah.
Have another in here.
We have enough people yet. So we have actually enough people coming that we
building resistance, lunch, and learn.
let's not do it.
Take time for more day.
I feel either way because I've also now been
This, but
This is everything related.
lives in right now I can get $3.99, but then they give me $100.
Somebody's coming here. Sorry.
Same deal. Same thing. I'm not. I used to be when I bought this phone and it couldn't do MMS messages or texts, but non-starter.
I was at Stack, and then I left from Walmart for about a year and a half. And still can't compare those, but it's been fun so far.
It should pay for itself like for a year.
Did you have this real?
I never.
So I joined the release engineering team. They're starting to do a bunch of Kubernetes work. Actually, a fairly small engineering team compared to the Twitters and the Facebooks. It's definitely nowhere near that massive amount.
Interesting to me. I always feel like there's
A lot of it is just a bunch of Python running and stuff. The ad server was ready to go. A few other bits and pieces here, but it's definitely
I'm not counting.
choice there. So it's kind of interesting because I hadn't done a ton of Python before.
Yeah.
They still run on the same servers everybody else does, so that makes it a little easier. Hopefully ads, they got a lot of eyeballs. They do have
start, but just because I got to play some team.
that's when you premium. It is a revenue source. It pays for servers, but it's definitely not like bringing in the big bucks that ads do. So we're trying to improve it, finding ways of making more. It's interesting. They just got a huge $400 million round from Tencent, so they don't need to worry about the money for at least a few more years. They're hiring. I think they announced 40 positions in Ireland, which would be their first big trip.
Yeah, it's probably
It's only like 25. Like San Francisco and New York.
so it's not as easy as Portland.
Doesn't have anything to do with like God in May.
Right? How much of it was like, let's get out of the US, and how much of it was like in the right time zone, and they have really, it's stacked in the same thing they had some people in that area. Same.
But what else is your offices there?
I don't know if it's stuff pushed towards that area, or like it just seems to be for a lot of people to hire from. The time zone stuff that we were looking at, just having people awake on the other side of the planet. From there to San Francisco, it is almost like a 12-hour shift. Yeah. So at Stack, it was like, it felt like tech, and while they had the Q&A sites for everything, it was very much like tech and like the internet. It was like the internet, and then Reddit's just the internet. Everything that exists on the internet is on Reddit.
Yeah, I think
It's changed. It used to be very pro-speech, and now they've dialed it back just a little bit and be like, well, we don't have to be, and we can have a little bit more nuanced policies. Luckily, I don't have to deal with any of that. There's like community teams, smart people, that kind of stuff, because they can have very bad weeks, that's for sure.
Should put the garage down.
Doing well for your enterprises.
Don't do this link. That is a great thing.
Okay, let's get started.
That's what I can say.
Welcome, everybody,
Very hard for us to find it
to
sometimes.
the Utah Go user group. Really appreciate you coming out. I know it's hard to get away from family and friends and hobbies, so we appreciate you taking some time to come out tonight. To start off, we're moving all of our meetups that we host at Weave to a foundation called Forge Utah Foundation. So feel free to join our Slack group or follow us on Twitter, whatever, if you want to stay in the loop on all the meetups we're adding. So I think we just added up to 6 meetups. We do cloud native meetup, machine learning meetup. We do, I guess one's in St. George, that probably doesn't appeal to you. And then we do like a front end craftsman meetup. So there's some good meetups to come to. So get on there and keep up to date. I will open it up now for any announcements that are non-sponsor related. So if you're hiring, you can announce that. But if you're trying to sell something, you can't. Anybody hiring Go developers or any developers that you want to announce? Yeah, Ulysses.
So I'm Ulysses. I work for Walmart Labs, and we have an opening for junior developer on Go. And if anybody's interested, reach out to me afterwards.
A junior developer opening. I think it's the first time I've ever heard that at this meetup. You're gonna get mobbed after.
Love it.
That's awesome. We need more junior developer roles opening up because it's really hard to break in sometimes. Anybody else want to announce anything?
Did you talk about Slack
Yeah.
and Twitter?
Yep.
We have an Instagram that nobody uses except for me. I got a follower today who helps Latin Americans in the tech community, so woot.
I did not know we had an Instagram. I'm glad we do. Okay.
Yeah.
Without further ado, I'd like to say thank you to Francesc for coming out. Really appreciate him taking the time to fly from the Bay Area to come to a lowly Utah Go user group, which is awesome. Francesc, I'll leave this at the podium for you. This is our little speaker presenter packet. So you got a t-shirt.
Nice.
And some stickers, and then the coveted Utah Go presenter pin that's in there.
Oh.
Yeah, so you can't get these unless you present. Can't get them.
I lost mine.
You see, and you can't get it back. You lose it, it's over. And so
Talk again.
I just expect this to be on your shirt always from here on out. Let's give him a round of applause.
So hi everybody. Thanks to you for inviting me. Actually, my first time in Utah. I'm hopefully visiting Salt Lake City tomorrow. So far, I've seen Lehigh, which is interesting. Yeah, I've seen like the mall right here. So everything I've seen of Utah, I cannot really judge. So today we're going to be talking about interfaces, then more interfaces, and then something else that is not interfaces, but it's kind of like interfaces. And then we're going to have Q&A. But in between, like, feel free to interrupt any time, just like raise your hand or shout out something. I'm happy to answer any questions that you may have in between. So what is an interface? Let's talk about an interface from the source of all truth, Wikipedia. It says, in object-oriented programming, a protocol or interface is a common means for unrelated objects to communicate with each other. Cool. What is important out of this? Communicate. It's about communication, right? It is, when you have an interface, it's not really about like what is the memory inside or anything like that. It's rather like how do you talk to it? Unrelated objects. This means that you do not need to know what's behind an interface, right? Because you know how to talk to it. So whatever implementation you might have is not relevant. It's concrete types are not important. We can think about the fact that you know how to talk to something. If the other thing on the side is a human or a robot or whatever, you don't care. You're still using the same interface, the same protocol, the same language. So I like to think about Lego pieces. If you think about it, Lego pieces, they have a very clear interface, which is that shape there, right? Like that specific shape of that specific length and everything, that is an interface. Because you can plug many different Lego pieces. As long as they all have this common interface, you can plug them together. When someone is building the red brick, they do not think about, oh, what is going to be on top, right? That is not a concern you have when you're building red bricks. That's, you only care about the red brick and the fact that it's going to match both interfaces, providing them and receiving them. So if you think about the piece, on top, it's kind of like one interface, and on the bottom is actually the opposite interface. Except that, of course, is actually much more complicated than that, right? When you have interfaces or protocols, you're actually talking about exactly how are you going to talk to someone. So if you think about protocols, like a famous protocol, TCP, right? Is TCP easy? Yeah, sure. Right? Like it could be easy, but once you get into details, it can actually get very, very complicated, right? So interfaces can be incredibly down to very, very technical details. And this is what I'm trying to show in here. And then we're going to try to figure out whether Go interfaces are enough to be considered interfaces even. Also, I guess that you have not seen a single talk without containers. So containers, right? Why are containers important to this talk? Because containers, everything there is a container, and I'm not talking about Docker right now, I'm talking about these containers. It's the fact that they're interfaces, right? You do not care about what's inside. You know how to handle that box, that container, whatever's inside, I don't care. So if I'm in the business of shipping things inside of that container, what I know is how to attach things inside so they don't break. If I'm in the business of transporting those containers, I don't care what's inside. And it can be transported in a train, it can be transported on a ship, right? So that's the whole idea of like having unrelated things working together efficiently. But what is a Go interface? So a Go interface is actually something a little bit more special because Go interfaces are the only types in Go that are not concrete. What does that mean? So we have concrete types and abstract types. Interfaces are abstract types. What are concrete types? So concrete types are the ones that describe memory layout. They tell you what they have inside. They tell you what they do. They tell you what they have, right? So if you think about all the numbers, like all the ints and floats and all that stuff, all of those are obviously concrete because not only they tell you that they contain numbers, but they actually tell you even how many bits they need to do so, right? That doesn't mean that you cannot attach behavior, right? But the type itself is that memory layout, really. So all of these are concrete types. So slices and pointers and structs and pointer to structs and all of these things and channels and maps, all of those things, those are concrete types. So what are abstract types? So abstract types are the rest, interfaces. And interfaces are interesting because what they do is they describe behavior. And rather than having some data inside, what they show is just what are the things that this thing can do, right? So a stringer is something that can string, right? It can convert itself in a string form that then you can print if you want. A reader is something that knows how to read. A writer is something that knows how to write. So if you think about it, when you have two different interfaces, what you have is actually you describing two different sets of concrete types. So the interface reader represents all of the concrete types that have the method read, right? That is basically what we're doing. We're defining sets of concrete types. And the interface writer is a different one. It's all of the concrete types that have the method write. So we have writers, we have readers, and then also we have things that are readers and writers, right? So what is that thing that is both a reader and a writer? It's a read writer, right? So this seems pretty obvious, but if you think about this, this is actually interesting because what you're doing is you're doing the union of the methods, right? A read writer is all of the methods of read and all of the methods of write. But on the concrete type side of things, what you're actually saying is that it's an intersection. It's only the types that have both of the methods, right? So while the interface is growing, the concrete types that satisfy it, that set is decreasing. It's getting smaller as you add more methods. By the way, you also can write it like that. So you have writers, and you have readers, and you have rewriters. What is that thing? It's a union of all of the concrete types.
Empty interface.
It's an empty interface because it's so since the union of the interface is the intersection of the concrete types, the intersection of the concrete types is not the union of all the concrete types is the intersection of writer and reader, which is empty, right? So that's an empty interface. So with this, basically, you have an idea of why do we have interfaces. It's just a nice way to talk about all of the concrete types without knowing which ones they are. Rob Pike said this, empty interface says nothing. And it is interesting because if it says nothing, what does this mean, right? For you, when it says empty interface says nothing. It is basically saying that we do not know what you have because you are restricting it to all of the concrete types, right? Anything could be inside. What can you do with it? Nothing. So it is kind of useless, but at the same time, if you come from C and you're used to like void, like start void, like the void pointer, it is not as bad as that. Like you are still, it's still bad, right? But from here, from an empty interface in Go, you can actually go back to the type that is inside. From a void pointer, everything you can do is just like be helpful. Okay, so my speaker died. Okay, so why do we use interfaces then? There's a bunch of different ways, different reasons. One of them is we write generic algorithms. And generic is highlighted because it's not about generics, right? I'm not talking about generics, I'm not talking about contracts, I'm not talking about any of those things. I'm talking about interfaces allow you to write generic algorithms. Also hiding implementation details and providing interception points, and we'll get that in a minute. So let's talk about interfaces. Out of these four functions, we have this function write to something. Which one do you think is the best? So who thinks the best one is A? Okay, who thinks the best one is B? Okay, who thinks the best one is C? Okay, most people. And who thinks the best one is D?
Yeah, I don't think I feel so.
No, why not? I mean, let's okay, so let's see, let's look at this, right? So if you have a pointer to a file, this seems very natural because you know, I'm writing to a file. So of course I'm passing a file. That's how it works, right? But the thing is that how do you test this? You need to create a pointer to file. And how do you create a pointer to file? Well, good luck. Like you can create a file itself, or maybe you have like a virtual file system somewhere, but that's not gonna be easy, right? There's ways of doing it, but it is not as easy as it could. The pros is nothing. Other than, you know, it is very clear that you can write onto a file. Like that works clearly. Okay, what about the last one? How do you write to a thing that is an empty interface, right? Like if I pass you, I don't know, a Boolean, how are you going to write to Boolean? Love to see it. And it's going to require runtime checks. Like if this works, if you have a function that receives an empty interface, it needs to do something about it. So if you think about like printf, print and println mostly, when you're passing something, you're passing empty interfaces. But we're actually checking, does this satisfy stringer? Does this satisfy error? Does this satisfy a bunch of different things to figure out how to handle it, right? So sometimes you're gonna see things like this, but in general, if you see this, it's because one, Go doesn't have generics. So sometimes you need to do these things. And two, bad design. Like there's better ways of designing than this. So what about these two? Well, it really depends, right? Read-write closer and writer, they're kind of similar. The only difference is how big they are. And if you're writing into something that has the read method, maybe you should change that function name because it's confusing, right? So probably it's gonna be writer because it's the smallest interface that matches what I expect to need to provide to be able to write something. So another proverb is the bigger the interface, the weaker the abstraction, right? So the bigger the interface, and the weird thing is that the bigger the interface means that the more methods you add, the smaller set of concrete types you're accepting, right? So the more methods you're adding, actually you're constraining your users into providing specific things that otherwise they could reuse easy. They could reuse your code easier if your interface was small. If you think about it, also it means that the strongest abstraction is the empty interface, which I'm just following logic. Oh, that's. There's a robustness principle which is very related to this. It says be conservative in what you do, be liberal in what you expect from others. There's a robustness principle that I took, I do not remember from somewhere, but it's like, I think it's one of the solid principles. But there's also the TCP version of it. So be conservative when you send, be liberal on what you accept. And this was actually mostly thought out for when you were doing network communications, right? So when people are sending you packets, do your best to try to parse them and try to understand them. But when you're sending something to someone, try to always be very consistent and very clear on what you're doing, right? So be conservative on what you're sending to people, but be liberal on what you're accepting from them, because there's going to be many different variations. So this keeps on dying. It's fantastic. That said, now we're going to be talking about abstract data types. How many of you have heard of abstract data types? It's like a computer science thing that I learned at university. Okay, I have not used this in depth, like ever. So, except for this talk. So, the idea is that these are mathematical models for data types, right? So, it's kind of like an interface, but on top of giving what are the things that you can do, you also say what are the possible values for a type, what are the possible operations, and also how those operations impact the value, right? So, let's see an example. So basically what you have is actions. There's an action that says, if you push something into a stack and then you go top, you will get what you pushed, right? This is like mathematical way of expressing these things. And it's a very nice way of expressing constraints on interfaces. So if you pop something, if you pop from a stack where you push something, you're gonna get back the original stack, or a new stack is empty, and a stack where you push something is not empty, right? Like all of these things are ways of expressing an interface, not a Go interface, but in general, the interface, the concept, the mathematical concept of what is a stack. So with this, with the abstract data type for the stack, you have these axioms, and you're already defining everything you need to know about stacks with this, right? So this is really cool. I think that this is a very powerful language that allows you to be very specific. So, is this the same? Right? Like if we transform this into an interface, you know, you can do push, top, pop, and empty. Cool. So, yes, so this is kind of the same because we're expressing the possible operations. But there's two things that are missing. We are not saying what are the possible values, and we're not saying what is the impact of doing things, right? You could implement a stack that just returns nil or empty all the time and whatever, like it will compile, right? So compiling against this interface is not enough to satisfy the abstract data type. But let's assume that this works. So what can you do with this? So one of the things that you can do is now you can start doing what we were talking about at the beginning, writing generic algorithms. So for instance, if I want to know the size of a stack, I do not need to know whether it is a vector, a linked list, or whatever it is. If it's a stack, I know that I can call empty, and I know I can call pop. So this recursive function is going to do exactly that. It's going to tell me how many elements are there in that stack. You might have seen this interface, right? The interface, gross name. But it's sort.interface, which then makes it acceptable. But the type interface is from the sort package, and basically it's something that you need to satisfy to be able to use algorithms like quicksort on top of this, right? And you have three methods: less, swap, and len. Cool. So what can you do with this? Well, you have a bunch of different algorithms. So you have sort and stable and sort and all of these things. They all accept interface, right? So the idea here is that if you're going to be building complex algorithms, so say you're going to be building something to find the shortest path in a graph, right? Instead of having a specific format for the graph with a concrete type, you could express what are the methods that you need in that concrete type. So you make it as an interface. So then you can reuse those complex algorithms on any type that you could create, right? That is a little bit the idea of the sort package. So you may remember these two. We have kind of the same, right? If you think about it, fprintln or fscan and all these things, they're actually providing kind of the same idea of, printing things is the strings is actually kind of hard. Printf is a complicated thing. How do you print floats and all that stuff? So why should we repeat that for every single concrete type? We're just going to say this is able to print into our writer. And what is a writer? That method. Same for reader. We can scan from there, right? So now all of a sudden you are able to remove a lot of repetition that you wouldn't need to have otherwise. So the question is this enough? Are interfaces enough to express an abstract data type, right? And no. So I love this example, type reader. So reader is the interface with the reader method. And all of these things that you need to make sure that you follow correctly if you want to be considered a reader, otherwise it will not work, right? Like all of these things are all of the extra conditions that basically saying, oh, when you're done, what do? Do you return 0 and nil or 0 and EOF? Or what do you even do, right? So all of these things are expressed in here. And that's the thing. Go interfaces are not powerful enough to express what an abstract data type is. A Go interface cannot express what a stack is, unfortunately. And that's fine. But it means that then you need to have documentation, which no one reads. So unfortunately, so there's a little bit of a problem. And there's a fix for this. Many packages, what they do is they actually provide tests. So you can actually have tests on an interface to make sure that they're actually doing what they're supposed to do. So the idea, if you have a stack, you could say, I'm going to check that when I call empty, it gives me something that the size is 0. Or when I call push, that it never says it's empty, or things like this, right? Like you can actually write those extra conditions as tests, and that will also work. Okay, so that's already what you send. Be liberal on what you accept. Let's talk of the other side. So out of these options, which one do you think is best? You do new and returns a pointer to a file. You do new or it returns a read write closer. You do new, returns a writer, or returns an empty interface. So who thinks is A? Okay, some of you. Who thinks is B? Okay, C. Okay, and D. You. Okay, so let's think about this, right? So you could think this is the best one, right? Why? Because the thing about it is that so following the robustness principle, you're being very conservative about what you return. You are saying what you return exactly. This is not a reader or writer. No. This is a pointer to a file. And that has a lot of value because then it means that I can use it as whatever I want to use it. If I want to use it as a reader, I can just pass it as a reader. There's nothing I need to do. If I want to use it as a writer, I can just pass it as a writer. Right? Like, I can use this pointer to a file in any interface as a parameter as a value for any type of an interface that this satisfies, right? So this is good, but it's actually not the best solution in all cases. So we'll talk about what solutions. I think I might have removed that. Let me think about this. Yeah, so this is the best one except for when it's not, and that's actually the next section. So if you think again about the robustness principle, be conservative what you send, you go on what you accept. If you translate that into Go, you get return concrete types, receive interfaces, right? The idea is that you're trying to receive the widest possible range of types, but when you're returning, you know what you're returning, and you should just return that. Unless, so I knew that was coming. So think about when do you think that using, like returning an interface could be better than returning a concrete type? While I drink water. Yeah.
I'll say as long as it's not a blank interface.
So the idea here is if you don't want to show the type, right? Like if you actually want to hide that concrete type, then do not return a concrete type. Examples. How many times have you seen a function return a concrete error type? Never. You always return the error. That's one case, right? But there's another one, which is when you actually want to decouple the implementation of the package from the API, right? If you're returning a concrete type, a pointer to struct, a file, right? And I add one more field to struct, that means that I'm breaking backwards compatibility. Sad. If I remove a field, I'm also breaking it. If I rename something, I'm also breaking it, right? So it is actually very delicate, and you're going to end up breaking things in the future. So it's a good idea when you're writing a package that is going to be used by many, many people to actually hide that type. So you can then refactor it without having to consider how people are using it, because you already explained how to use it through the interface that you expose. Error is a good example of this. The type context is one of the best examples of this. So context, what's inside of context? You probably don't know, and that's great, because you don't care, right? And it's not because you don't care about context. You should care about context, but you do not care about how it's implemented, right? You know how to use it, you know that it works, and that's everything you care about. So the context type, I gave a talk about it, but really quick. The context type is actually quite old. It was created internally at Google as an experiment to pass things around. And it looked like this. There was a context interface and one single concrete type, the context type, that was not exported. And it contained all of the things. So if you think about it, what you're doing with context is you're actually chaining them. So if you chain all of those, and every single context has the information about what are the values, what is the timeout, what are like all of the possible options of what a context could do, they need to be in memory, right? So you end up repeating that piece of memory very, very often, which actually became a problem. So they did this. And actually now, in the standard library, what you see is not one concrete type, you see four. You see one, which is the empty context that doesn't do anything, and it's an empty struct that contains 0 bytes. You have the cancel context that knows how to handle cancellation. That's everything it needs to know. Then you have the timer context and the body context. And all of these 4 different ones know how to do one thing, and they're able to keep only the minimum size of memory that they actually need, right? This kind of transformation would not have been possible without interfaces. If these context.context return a context struct, sorry, but no, you cannot do that anymore, right? So when you're building packages that are gonna be more of an infrastructure to bigger systems, it actually makes sense to protect yourself. And even though we say you need to be conservative with what you send, it is probably better to hide it to avoid basically being too dependent on that early decision in the future. So interfaces allow you to do this. You can hide implementation details. Then there's one more thing, which is call dispatch. And this is actually something that makes interfaces really powerful. Without this, it wouldn't make sense. So what does f.do? It's complicated. What does this code do? So, well, it depends on what f is, right? Think about f being a pointer to a file, right? We're going to go and call the do method that is defined on pointer to file, always. And at compile time, we can see this code, see that f is of that type, and we can just encode that, hard encode, and say, you're calling this area of the code, exactly this one. Or f could be an interface. And now what does do call? Well, it depends on the type that you have. So now instead of having a dispatch, a call dispatch that is known at compilation time, this is what we call the dynamic dispatch, right? So it's gonna be later on, we're gonna try to figure out what is inside. So two kinds of the call dispatch, static and dynamic. Concrete types are static. So they're known at compilation, they're very efficient, it's just a function call, there's nothing else to be checked, and you cannot intercept it. That's it. If you're calling f.do and f is the file, you're calling that function. There's nothing else you can do about it. Abstract types, though, they provide dynamic dispatch call dispatch. So it is not known at compilation. We do not really know what method we're actually calling, to the point that if the value of the interface is nil, there's no function to be called, so it will panic, right? So you do not know that until you're running the code. It is less efficient because first you need to figure out what is the type that you have under the interface, find what is the corresponding method, and then call it. But it allows you to intercept it, which means that you can actually put stuff in between. Because since there's that step where you're trying to figure out what is the thing to call, there's actually ways of changing that while the code is running. And we're gonna talk a little bit about that. So let's think about the round tripper interface. The round tripper interface, which is an interesting name. It's an interface that has round trip, but you could call it also transport. It is actually the name of the field in the HTTP client. It's called transport, right? So what does a round tripper do? You give it a request and it returns a response and an error. What is this supposed to, why do we have this? Well, because HTTP and HTTPS and HTTP2 do not work the same way, right? So actually have different transports that are able to handle different specific ways of sending those requests. But it also has some extra powerful things, which is, so when you have HTTP client, when you call get, right? Calling get on HTTP client, it's going to eventually call HTTP default transport if you don't do anything. But actually that's through an interface. So you can define any other interface like this one, which is a headers type, that everything it does is satisfies the round tripper interface by just adding a bunch of headers to the request, right? So before it sends it, it goes through a list of headers that it has in the map, and it just adds all of those into the HTTP request, and then it sends it. Cool. What can you do with this? You can put it in between the default client, or whatever the client you had, and your, in between the default transport, whatever transport you have, and the client. So now when client is going to access this transport, you're actually adding extra behavior in between, right? This is super useful. And this is something that in general, when you see any interface in the standard library, this is mostly the objective, right? These are ways of adding extra behavior. So you think about string, the string method that returns a string. That is an interface stringer. And what is the goal of defining that? Changing the way you print things, right? So you're adding new behavior to the thumbed package, actually. Because the thumb package is it stringer instead of thumbed? Yeah, I think so. So basically the stringer interface is a way for the thumb package to give you the opportunity of changing things later on. So yeah, you can do these kind of things. Once you're able to put one interface in between, you can put many. So these actually, when you think about the read or write methods, reader or writer interfaces, the cool thing about those is not the fact that they exist. That's cool. But the fact that you can actually chain a bunch of them, so when you do IO copy from a reader to a writer, you actually have no idea what's going on to get bytes and to send those bytes later on. IO copy doesn't care. It doesn't need to care, right? So these are actually really powerful. Things like this that you can define high, like algorithms that are gonna be very, very high abstractions, but you don't care if the data is coming from a network connection or from a database or from a file. You don't care about those things. So let's write some code. So this chaining interfaces. So I have that string in there. Good night. So I have that string in there, and what I'm gonna do is I'm gonna create a reader. So that reader, I'm gonna create it with strings.new reader. So that gives me something that reads from that string, but it is a reader. So now R is a type reader. Cool. Then we're gonna say, oh, that looks like base 64. I'm going to do base 64, the coding from that. And then you're gonna get a new reader. And then, oh, by the way, this actually gives you something that is binary and turns out to be zipped, compressed stuff. So I'm gonna decompress it, uncompress it. So I'm gonna use that gzip new reader. And then I'm gonna copy from here to the output, right? So now when I call copy doesn't care about what's in there. It just knows it's a reader, so it calls read. The gzip reader, what it's gonna do is it's gonna say, oh, I need to read the gzip header from the reader that I was given. Cool. That is actually a base 64 reader. So the base 64 is gonna say, oh, I'm gonna read the first chunk of things that I need to read to be able to decode it to go back to the thing that I have. Sure, but how do you read that thing? Actually, that comes from the string, right? All of those things, all of those chains, IO the copy doesn't care. Those are completely hidden. And that brings something in Chinese, because I prepared this talk for China, for Shanghai. I think I'm able to pronounce it. I think it says something like, no, that's totally wrong. It's, oh, that's like bad hello. No. I've been learning Chinese since then. Like, that was long ago. But yeah, interfaces also provide interception points. And not only that, but those interception points can be reused to create chains. Okay, so those are all of the things that we can do with interfaces. We can write generic algorithms like sort and stuff like that. We can hide implementation details like for context, and then we can provide interception points. Interception points that you can think about like reader and writer, but in general, I like to think about like stringer or JSON marshaller, JSON marshaller, all of these things that are going to allow you, for instance, if you want to control how something gets marshaled into JSON, you can define the JSON marshal method that will make your type satisfy the JSON marshaller, and the JSON package, once it starts marshalling that thing, will know that it actually needs to call that method instead of doing the normal thing with structs, right? So that kind of idea is the whole idea of interception points. So what's new, right? Like, this is exactly the same for every single language that has interfaces, including things like C++, which doesn't, or maybe it does now, because I stopped following after 11, so I don't know. It might have interfaces. I don't know. Probably not. But the idea is that this is like nothing new in here, and especially if you come from like Python or Ruby or JavaScript, where you can do all these things. Of course, like it just works. So what's new in here? Just one thing: implicit interface satisfaction. That is the thing that I actually really like of Go interfaces. What does that mean? No implements, right? And this for Java people. So the traditional thing is implements this interface and this interface and this interface. Cool. So what do I need to do if I'm using a package? Imagine that I'm using some open source project and I want to use that type as my own interface. So it's easy. You go modify the code, add your own interface. No, that will not work, right? So you need to find some ways and proxies and things like this, because it will not just simply work. You need to add that implement specifically. So I wrote this long time ago. This was actually my second Go project ever. So the first one was too bad to publish. So, so what this does is you give it a mathematical expression and it will create a plot. And all of this is running Go. So since I'm a good software engineer, I did packages, and I did two of them. One is parse, the other one is draw, and that's what they do. So package parse, what it does is, given a string, it returns a function, okay? And how it does it, it's magic. You don't care about that. It's gonna parse things, and then it's gonna provide a function that has one method, eval. And when you call it with X, it returns Y, right? So if you parse X squared, and then you say, okay, so need this word, I have this parse.func value, I can call eval of 2, and then we return the square, which is 4. Okay, that's what it does. Then, on the other side, I have draw. And draw is something that, given a function, is going to go by all the values of X, find the Y values, and plot them on the line to create that plot. Cool. So this is the normal way you would do it, and this is actually the way I did it. So draw depends on parse. And this seems okay, right? But the thing about this is, okay, so if I want to test the draw package, I need to first create a parse value. I need to create a parse.func, because that's what my method receives. If you want to avoid that, in other languages, you would do this. You have a common package that defines an interface. So now your package draw receives an interface, and your package parse returns an interface. So now those two are interfaces, and all packages know each other, and that's fine, right? But now you have the one extra package for literally nothing. In Go, this is the way you do it. You just have parse, and you have draw. And it just works, even though they don't know each other at all. How does this work? So it's actually pretty simple. Instead of importing parse and doing parse.func, you define evaler and receive that. So now what I'm doing is, oh, give me anything that has this eval method, and I know how to handle it. The rest of the code will work, because all of the places where you were using a func.parse, a parse.func, you can still use it as an eval, and this will work, right? So thanks to this, now testing this is very simple. So you can actually define the eval method on a function and have, you know, like, I'm going to use math.sin and use, or cosine or whatever, and I'm going to be able to get all of those things that are nice to test directly onto my test without having to declare them through parse. So yeah, interfaces can break dependencies, and they make your code more reusable and more testable. So whenever, but all of this is under the condition that the interface is defined where you're going to be using it, right? You define the interface in the place where you actually call eval. You don't define it in parse, otherwise you still have that dependency. So yeah, define interfaces where you use them. So the traditional question when I tell this to people that do not know much Go is, but how do you know what implements what? And the answer is, you don't. Like, good luck. There's actually some tools to do this. Guru has any, do you know Guru? Okay, so not that many people. It used to be called Oracle. Oh. The name changed for obvious reasons. Yes, because, you know, Google open sourcing a tool called Oracle was a little bit weird. But yeah, Guru is a really cool tool that is able to basically answer questions. And those questions can be quite advanced. So here, for instance, there's a packet, that URL links to a blog post that explains how to use it. But basically, you can ask things like, oh, this value here, the response writer, what are the things that satisfy response writer, right? You can ask. And it will tell you that all of those things, the http.response, http.public response, all of these things, if you notice, they all have lowercase, right? All of those things are non-exportable. But you can actually see what are the things that satisfy that interface inside of your Go path. So that's pretty useful. And actually, not only that, but if you use GoDoc, you can say -analysis equals pointer, and it will do something similar to this. So in the documentation, you'll be able to see for every type, what are the interfaces this type satisfies, and for every interface, what are all the types that satisfy this interface. So that's pretty useful. I do not think that this works right now. Like, if you go to godoc.org, let's get this, and you get a concrete type. No, this doesn't work. But if it's working, you would see right below there something like type information or something else that it's details, and you can open it and get more information. I recommend having it for basically if you have a local GoDoc instance for all of your internal projects, definitely do that because it helps a lot to understand what are the types that you have. Okay, so what is the superpower of Go interfaces? Type assertions is actually the difference between empty interface and void star, right? Like void star, good luck. Empty interface, you still know what you have in there. So you can do a type assertion to a concrete type, right? So you can say, yes, I was given this as an empty interface, but I think this might be an integer, so I'm going to say, give it to me as an integer. And there's two ways of doing it. The first one, which is the brave one, that will panic if it's not the right one. And then the second one is the one that you should be using in general, where you're checking in if it is not the right type, rather than panicking, okay, it will be false. So you can check. And then I will actually be the zero value of the type. So it's kind of like channels. When you're receiving from channels, kind of the same behavior. Cool, so this is great. There's even more than that. I don't know if you've seen this. This is a very awkward syntax of Go, where you can actually do a switch on a type. And all of the expressions, now they're not expressions, but they're types. So all the cases. So here what you're saying is, check what V is. And if it's an integer, do this. And if it's something else, default. It is kind of cool. Also, don't do it. And I'll show you why not to do it in a minute. There's actually something that's exactly the same, but is good to do. We'll get there in a second. You can even do this thing. You can do a short variable declaration inside of the switch with a type. And now T will change its type in every single case. So case int, T is of type int. And default is of empty interface. So this is actually kind of cool because it allows you to avoid, very often, if you wanted to do something with V in here as an integer, you would have to first cast it to an integer and then do something. So this avoids that. This already gives you a variable that is of the right type. Cool. Oh, no, I didn't want to show you that yet. Okay, so what is the problem with this? The problem with this is that, okay, so this was for int. Cool. What about int 16 and int 32 and int 64 and all of those, right? That will not work. You need to add them. And what if you forget one type? You're out of luck. You need to keep on adding more and more and more and more concrete types over time. And that's bad, right? It's actually basically bad design, because what you're saying is every single time that someone wants to use your library, they're gonna have to hack something and add their own type into a list of things that are accepted. So instead of doing that, what you wanna do is not work with concrete types, but with sets of concrete types. And what is a set of concrete types? Interfaces. So you can do the same thing, but now what you're saying is, does this satisfy stringer? And this is interesting because there's an empty interface, right? So you're asking, does this empty interface satisfy stringer? The answer should always be no, because the empty interface doesn't have any methods. But that's not what you're asking. The question is, does the value inside of this empty interface, is the value from this, is the value behind this empty interface of a type that satisfies the stringer interface, right? So if you have a file inside of that empty interface, that will actually work. And that's kind of confusing, but it's incredibly powerful, because it allows you to, if you are, say, the thumb package, say, oh, does this satisfy stringer? If it does, then I'm going to call string method instead. And this is exactly what the stringer package does, what the thumb package does. You can do the same thing for this context. So you can do thumb.stringer as the case. So now all of the types that satisfy that interface will pass through that case. And you can do again same thing and declare a short variable declaration. So where do you see this? It's actually where all of those interfaces that I was telling you are extension mechanisms or interception points for the standard library. Those interfaces plus the capacity of doing this check are the things that make this possible. So you're gonna see it in thumb.stringer, but also marshaller, and there's many, many, many other interfaces for which the whole point is, by default, we do one thing, but if you satisfy this interface, we're going instead to call that method. And this is actually something that I recommend if you're using a new package, in the standard library, first thing I'm going to read is all of the interfaces it provides. Because that in general is all of the parts that nobody really talks about, but they're actually really powerful. So try to check those. So yeah, you can use type assertions to extend behaviors. Dave Chaney has this really great talk, which is also a Go proverb. Don't just check errors, handle them gracefully. And he talks about the context interface and the fact that, well, he doesn't talk about this, but he talks about things that made me think about this. So I'm going to be talking about this instead. So the context interface has a method R or err that returns an error. And that error can be of two types only, canceled or deadline exceeded. Those are the two types that it can return, okay? Let's see the definition of cancel. Errors.new, context cancel. Cool. That's not very useful, but this is what it does. Cool. What about deadline exceeded? Interesting. The deadline exceeded exported variable is of the type deadline exceeded error, which is not exported. And this is weird. But it is actually not weird because the type of the deadline exceeded is not deadline exceeded error. It's actually error. It's an interface that we're putting that value inside, the deadline exceeded error inside. So this works. And why do we do this? Why do we have this type? Because on this type, we define three methods: error, because it needs to be an error, timeout, and temporary. And they always return true. So this seems kind of pointless. Why would you do a function that always returns true, right? And the thing is that you can do this. You can check whether an error satisfies the temporary interface, and then call that temporary, and that will return you a Boolean. If that is true, it means that this error was temporary, so maybe try it again. And if not, we know there is actually something fatal, you should never try, right? Like this code works because error, which is an interface that only has error method, contains types that could satisfy all the other interfaces. And I think that this is really cool, and we don't see it that often. So yeah, use type assertions to classify errors and watch Dave Chaney's talk. And the last thing that we use it for, and this one is the one that I really, really like, because it basically it fixed a big problem in the standard library that otherwise would have broken backwards compatibility. So the response writer type has been there for a while. It has header, write, and write header. That is the interface it has. And that's it. And if you add a new method, then you break all of the code in the world. So congratulations. You cannot do that, right? So now HTTP2 arrives. And on HTTP2, you can push things. So how do you do it, right? How do you say that you can push things and add it to a response writer interface that people are already using without breaking everyone's code? The answer is you cannot. You cannot add things to that interface. But you can actually do something kind of cool, which is you add that new method to all of the implementations that can do that, right? So in our case, it will be only HTTP2. If you're doing HTTP1, there's no point in having a push method because you don't know what to do with it, right? But HTTP2 can do that. So you add that method first. Then you define an interface that contains only the new method. So it's not a response writer with all of the methods that it had plus the new one. No, it's just one interface that has that new method. And then you document a lot because you want people to read it and notice that this is actually how it's supposed to be done, which is actually not very easy. So this saved the world because otherwise everything would have been broken. But at the same time, it makes for a slightly awkward piece of code. So let's see how this works. So there's an HTTP pusher interface that I don't know, has anyone seen this interface before? I mean, yeah, people working in like HTTP servers, that would make sense. But yeah, like this interface is something that we don't see very often. But what you can do in an HTTP handler is you can check, does this response writer satisfies the pusher interface? And if it does, I'm gonna push my resources, right? That is again the same mechanism of saying, you know, this interface, the response writer interface, is something that allows you to do most of the things that you can do with response writers. But if you want to push, there's like a extension mechanism where we're going to have a different interface that provides that. In order to check it, you do it with a type assertion. I think that is like beautiful, but also don't do it if you don't need to, right? Like this, we had to, so we did it. But if you can avoid doing this and just, you know, like design your interfaces correctly from the beginning, that'd be great. Except that it's impossible because you could not have guessed what HTTP2 is going to do before HTTP2. So yeah, use step assertions to maintain backwards compatibility and save the world. So in conclusion, interfaces provide generic algorithms, hidden implementation, interception points. The fact that the satisfaction interface is implicit allows you to break dependencies across packages. And then type assertion is magic and it allows you to extend behaviors like marshaller, stringer, all that stuff, to classify errors as temporary or not, and to maintain compatibility when otherwise you couldn't. So interface is great. Whoops. So what about generics? So, have you heard about type parameters? Raise your hand if you've heard about type parameters in Go. Okay, not many people. I read the documentation. It was intense. It is. I recommend, I think that I have a screenshot of after 50 pages, it says, but now let's get in detail. It's like, when I got there, I was like, I think I'm done with this. But the idea is that, so we were saying that sometimes empty interfaces are used because Go doesn't have generics, right? And this is true. Happens often, not all, no, it happens sometimes, not often, but sometimes you'll see places where having parameterization of types or generics, as you call it, would make for better code. So for Go 2, there's this proposal. Not necessarily Go 2, by the way, it could be done without Go 2. But this proposal adds type parameters to functions and types. So let's talk real quick about that. This is what it looks like. Yeah, I really think it looks a little bit like true functional programming with two, like, I don't know exactly what it reminds me of, but not Go. So yeah, like the first parameter list is actually not the parameter list, it's the type parameter list. And then you have the parameter list, and then you have the return value list. In this case, it's empty, so it's not there. So then you could do things like, I'm going to have this print method, print function that given a slice of stuff, it just goes over all of the elements in the slice and prints them, right? Cool, this works, awesome. We're done. Now we have type parameters in Go, sure. You also have type parameters on types. So interfaces are not always enough, especially if you read packages like, I would say even sort, but there's a ring, there's a containers directory in the standard library with a bunch of packages that I'm sure no one has ever used that basically provide interface, like ways of managing things like ring buffers and things like this. And they always use empty interface because otherwise, what are you going to put in there? The only reason why we do not use anything in there is because we actually have map. And map, it's type parameterized. It's a hacky thing, but in Go, you have a map of something and a slice of something. And those, if you think about it, those are type parameters, type parameterized types, right? Those are types of the type. So yeah, so these are things that could help for type parameters. So you could have something like a type stack of a T, type T is a slice, right? And you're gonna be able to satisfy this. And then change this, like instead of having a stack of integers, I want to have a stack of strings. You can just change something and it works. If you try to do the same thing, which I have to try to implement a stack using the stack package in the standard library, every single time I've implemented it wrong. Because it turns out that you're supposed to start from the beginning and I always start from the end or the other way around. So yeah, you need to read the documentation. That's the problem. So with this, you don't need to read that documentation anymore. Again, the syntax here is kind of cool. Func s stack of t. Kind of a weird thing, but this is the proposal that we have so far. But the idea is that with this, now if I want to use a stack of ints, I can just say s colon equals stack of int. That's it. Now I have a new type. That's great. Is this enough? Well, no. What if you do max? I want to get the maximum value in this, right? Sure, this works. Yeah, sure. What if you pass a slice, right? You're comparing slices. Well, Go doesn't allow you to compare slices. So, nope, you cannot do that. What if you compare functions? You cannot compare functions. What if you compare, I don't know, maps? How do you compare a map? How is a map bigger than another one? That doesn't make sense, right? So there's a lot of places where this code doesn't make any sense. So that's where, well, so yeah, if you call it with integers, it works. With float64, it works. With string, it works. With Boolean, is true bigger than false? Maybe. Maybe. With slices of bytes, you're out of luck. That doesn't make sense in Go. So that's why we have type contracts. And the type contracts provide a set of constraints on types. Interesting, right? Like that is what an interface does. An interface is a set of constraints, a series of constraints to define a set of concrete types. So this is the same, except that it doesn't say on types, on concrete types. It says on types. You can technically have interfaces inside of contracts. And I'd rather not think about that. But you can, right? Like this is a little bit more general. It's actually not only for concrete types, for all types. You can have any type of type parameter. And they look like functions, which is kind of weird, but basically when you have, there's a contract that allows you to say that a type is comparable, right? You can compare it to itself. So you're saying, it is really weird code. I think that this is very confusing. But the idea is that if this compiles, then you're good, right? So the idea here is that, oh, contract comparable of a value of type T, I need to make sure that this makes sense. So if I do V is less than V, return something which is a Boolean. Cool, so you can do this and it works, cool. So now you can say func max of type T, which is comparable, that's this. And now actually you're actually basically putting that series of constraints on what you can pass to a type parameter. So this works, and we're all happy. So let's think about a type with length. So there's a type for which you can call len, and it will return an integer. Slice or map, or there's actually a bunch of them, right? So you can call it on slice or map, and I think that's probably pretty much it. Yeah. So let's go back to the thing. So the contract reader, if you define a contract that says, oh, you need to have the read method, as in the reader interface, right? Like you have a contract reader, and you also have a contract writer, and you can do that same thing. Like if you're able to express a set as an interface, you can express the same set as a contract. Those things work. But you can express things that before you could not. So whether something is comparable or whether something works with a len predefined method, right? Like those are things that before you could not do. So contracts are more powerful. So we should always use contracts. Nope. So interfaces are contracts. So the interesting thing is, while you can say that those two things are the same, like a type stringer interface, which is a string that returns a string, is basically the same as contract stringer that does the same thing, called x.string and returns a string. So it's basically the same thing in a convoluted way. This is not enough. Because when you have a comparable, right? When you have that comparable, you cannot represent it as an interface, which is cool. So this is something that is more powerful, I guess. But if we put the comeback in contract, that was very funny that day. All of the idea of having dynamic dispatch is gone. Because contracts do not exist at runtime. Contracts are a compilation concept. Only compilation. And once you've compiled, that type is gone. You will never see it, right? So all of the places where we're depending on dynamic dispatch to be able to do cool stuff, gone. You cannot do that with contracts, right? So that's a little bit of a problem. It has this good side effect, right? The type system doesn't need to change. Why? Because it's not changing. The contract is not, the reflect package doesn't need to know about contracts because the reflect package only knows about types that exist. And contracts do not exist for the runtime. They only exist for the compiler. And so, yeah, like it is simpler, but on the other hand, you had no implementation. When you have a contract with a type inside, you're actually able to see that type, so you're not hiding anything. And there's no dynamic dispatch. So all of the benefits from interface are gone. And I would say that not only they're not enough, like contracts are not enough as they are, but also they're too smart. Even after reading all of this, after reading the whole documentation, I don't understand them. I sincerely think I understand them enough to be able to talk about them for an hour. But if I'm writing code, I'm pretty sure that the code that I'd be writing now with contracts, in a year, I'll be ashamed of it, right? Because we still do not understand how to use them. And that's a little bit of a problem. And for an example, oh yeah, so 42 pages total. And I think it was like page 30 or something that it literally says, let's get into detail. And I was like, whoa. But yeah, this is an interesting document. It is pretty long. It is very well written though. So if you feel like reading something from the Go team, I would definitely check this out. So why do I think that they're too smart? So the comparable thing that we say, oh yeah, v dot equal v returns a Boolean, right? Like that is enough because you're basically transforming that interface you had, equaler, into the contract. Yeah, but what does that mean? It means something that you call it with itself, and it compiles, and it returns a Boolean. Does that mean that it needs to be exactly the same type? Could it be a different type? Is it a pointer? Is it not a pointer? Like all of those things, all of those possibilities actually satisfy the contract. And I do not know if that's what I want to do. Right? Like it is this part, which is like, it is actually very hard to tell what your contract is actually defining. The set of types that satisfy that contract, it is tied to like very subtle things like, yeah, v equal v. Sure. Like there's many things that could do that. An interface, like if you had this, v equal t equal t, right? You're basically saying it's an interface that is able to compare it to itself. You cannot do that with interfaces, right? You cannot have an interface that just says, oh yeah, you need to pass the same value as I have. For that, you need contracts. But even when you have contracts, the way you express it is incredibly confusing. And you end up with things where it's actually very hard to tell whether the author that was intending to do this or not. So that's the part that I don't really like about contracts yet. I think that eventually we'll get to figuring out how it's supposed to work. I think that the mechanisms behind contracts are not bad. It just we don't have enough experience with it. So to finish, the left side, I already said it. So what would contracts provide, right? Well, generic algorithms, which right now we basically building with interfaces, and things like sort could be much easier to do with a contract. Generate types, so you could have things like a vector of things or a graph of things, right? Like those things, we cannot have them right now. And then also even cooler stuff, like imagine since you're able to work with a parameterized channel, you can say, you know, give me a channel of something and I'm able to merge multiple channels into one. Like I can do demultiplication, multiplication, all of those things that we write all the time because we have to, because copy paste is the only way of doing it, because otherwise it will not work, right? We could build libraries for that. We could even have, I gave a talk a long time ago. The title was Functional Go with a question mark, and the answer was no. And the answer was no, because if you try to define lambdas or whatever it is, turns out that you actually end up needing a lot of either reflect package, which makes everything incredibly slow, or contracts. right? So it would allow you to all of a sudden handle Go as a almost functional program, functional programming language, which I'd be really excited about. Like, I think that there's a lot of things that we can learn from Rust. And the thing that's stopping us is actually contracts. So it'd be awesome. But at the same time, contracts are maybe not the right solution. And then also it would remove things like bytes and strings. Bytes and strings are basically the same. The only difference is that strings are not mutable. Bytes, like slice of bytes are. And we have two different packages, which literally are copy-paste of each other, just for this. It doesn't look good. And kind of the same, if you ever call things like, how many times have you written the function max? Yeah. So, right, like max for what? Well, int 32 bytes, all of those things. Like, you need to write them every single time. It'd be great to be able to do that just like using a library that provides these contracts, and it just works, right? So there's a lot of things that contracts can bring, but I'm not sure they're still the right answer. So in conclusion, interfaces are great. I keep on using them. They're, for me, the best thing of Go by far. They're much better than concurrency. Type parameters are great. Type parameters, the type parameters themselves. Contracts, though, they're interesting, but maybe a little bit too complicated for what we want to build. And the thing is, if you think about Go, the whole message behind Go, the whole philosophy is simplicity. And contracts are not simple. So we need to think something better. Thank you. So I have 23 more slides or questions. Yes.
So you gave, when you were talking about type assertions, an example of like having to type assert to an int.
Yep.
It seems like interfaces could help. Why don't we define the mathematical operations in terms of interfaces? Like,
yeah, so yeah, like the idea is interfaces are not as powerful as contracts because contracts are able to do things on operators. So we could make operators be methods and then define interfaces where you're saying, oh, this is something that you can compare. And like the less than becomes a method. This is what C++ does, right? Like operator overloading. Somehow it goes against the Go philosophy. I used to believe that I was right answer. I'm not sure anymore. I think that operator overloading would make Go very powerful for things like I'm writing a thing where I'm building like a neural network from scratch in Go. And yeah, like the TensorFlow with Python is amazing because you can redefine what plus means, right? In Go, you cannot do that. So operator overloading would bring extra complications, though. So in between having operator overloading or having contracts, I'm not sure. I think that they're both solutions to a bunch of different problems, and the intersection is not empty. Like there's some problems that could be solved one way or the other, and this one is one of them. But I think that operator overloading is not, like the complexity that is added to the language is quite big because they would exist in the runtime, while contracts do not impact runtime. So it's a trade-off. Yeah.
So like both of those proposals, all the ones that I've seen relating to generics, it seems like they want to throw a bunch of weight in at compile time, or
yeah.
Through. And so isn't that one of the big reasons to move away from C++ is the
I mean, there's many reasons to move away from C++, but and the compiler doing like 7 passes over every single file is one of them. I'm not sure. I think that the fact that we're going to make the language a little bit more complicated and the compiler slightly slower, it's not really that much of a big issue. We are not, like the compiler is, compared to many other languages, is incredibly fast because the language is very simple. I think we can add a little bit of complexity and still be fine, I think. But yeah, there's a generic list of requirements to generate proposals, I think it's called, or something like that. I mean, there's that document actually where people were sending links to that. Golang generics, generic requirements or something. So, I don't know, it's not here, but whatever. There was a document that explained all of the things that you had, like your proposal had to, all the properties your proposal had to be considered as a thing that you could actually propose correctly. One of them was the fact that the runtime cannot be any slower, the code cannot be any bigger. And so, yeah, code bloating, not okay. Boxing, not okay, because then you need to have an extra thing to check, which makes your program slower. And then there was a couple more. And basically with all of those constraints that the Go community kind of agreed that they were really important, there's not that many solutions. So yeah, contracts are the first time that all of those things are matched, which is, you know, it's a good start, but doesn't mean that it's the right solution. Yeah, this, so Ian Lance Taylor, which is the guy that wrote this proposal, it's probably like the 6th or 7th proposal for generic that he's written. So, you know, it's pretty good. Yeah.
So I've been using Go for years now, and I don't really think of interfaces in any other way anymore, like the old, you know, Java programs I used to write where I had to explicitly say I implemented an interface. But now you got me thinking, did we, I mean, there's no free lunch. Did we trade something when we implicitly satisfied interfaces? I mean, they seem like kind of the holy grail of.
I do not think so. I think that the only thing that we lost is the fact that your code will break faster when something is wrong, right? Like if you're saying I'm satisfying that interface and then that interface changes, then my code will break because you're not satisfying that. So the error message for that will be incredibly clear. It will be, you're missing this method. You cannot satisfy this interface. But you can do things to have that security back. So you can, I don't know if you've ever seen this traditional hack that you can see normally in auto-generated code, but if you have like type, foo, struct, whatever, and you want to make sure that this foo type satisfies the interface stringer, you do this. This doesn't have any effect in the runtime, doesn't make your program slower, but if you try to run this, it will not compile because it will say that funded stringer is not a thing. But yeah, you're basically going back to that error telling you, it's like, hey, you're missing this, right? So I've seen these normally in auto-generated code, like everything related to protocol buffers, there's things like this. Yeah, like that's where probably if you've seen it somewhere, it's because like when you're auto-generating your code, you want to add as many layers of security to make sure that what you're generating is actually correct. I would not recommend people writing it as a debug technique, kind of works. But yeah, I do not miss this, to be honest. And I think that that's probably the biggest thing that we miss is the fact that we do not have a concrete list of interfaces that satisfy, which means that if that list changes because an interface changed, you might not notice.
I see.
Right? So yeah.
It also cost you like a default implementation for a method on the interface. They don't have to continuously re-implement it and stuff.
Oh, you mean like
if you rewrite max or something?
No, so if you want to do, if I understand the question correctly, is what you're asking is if you have an interface, say like read write closer, and you say I want to give a thing that has like a default implementation for close, right? No, Go doesn't do that. There's a way of doing this when you want to be kind of lazy. Which is having basically a default implementation that you can embed into your types. So you can have like, in this case, you would have something which is like the type fake closer that is a struct that has the fake closer close error. And then if you define a new type, which is read write closer, struct, then you can do fake closer, and that will add the default implementation to close, so you don't need to rewrite again. I've done this for tests and stuff like that. I think that the code at the end ends up being a little bit weird, so I do not recommend it. But if you see, is the package util? No, IO util. It has nope closer. That's basically what it does, right? It adds that, oh yeah, and this does also a close, and the close doesn't do anything. So yeah, there's ways of doing it, but it's not part of the type system. It's actually part of the code that you write. Any other questions? Yeah.
So in the current issue I'm working through on a project, I'm using interfaces as a way to avoid ridiculous amounts of custom code. There's a lot of detail in that, but the question I have is there any issues that come up from defining a method in your interface and then not defining the function associated with it? If that makes sense. Say you have an interface and you have 5 methods with it, but for a certain type that you're acting on, you only want to use 4 of those methods. Would the 5th one?
I would actually define multiple interfaces in that case.
Okay.
I would definitely have, the thing is, this is not Java, right? And I'm not saying it is a bad thing for Java, but in Java, interfaces tend to grow over time, right? In Go, it is better to have the smallest interface possible, right? So that's why we have read, write, closer, but also reader, also writer, and also closer, right? Because if you want to use just reader, why should you ask for more? So in your case, if there's like some kind of different cases where there's like the one with 3 methods, actually, let me show you some code that I've been writing. So, so there's a neural network in Go, and so there's a type somewhere, predict. I think it's gradient descent. Yeah. So there's an interface which I didn't pay attention to the names, but that is trainable predictor with gradients, and then there's all of these things, right? There's also the possibility of saying, you know what, like since I'm not using this all the time, this is one and this is another one, right? Like, so you can break your thing into pieces.
Okay.
And that way, like if you want to use trainable predictor with gradients, you say, oh, that's that one. Imagine that like with gradients, this actually had it before. So the code before was like this interface. Let me remove that thing. And then what I did was interface inheritance. But basically what I'm saying here is that there's the interface, the trainable predictor, which is something that I can predict things on, but also for some cases I need gradients. And in those cases, I'm gonna have those extra 3 functions.
Okay.
Right, so you can have that and have multiple layers. That is a way. The problem with this is that you basically create a hierarchy, which is a very non-Go way of doing things. For sure. In Go, I would rather say, if you can, have them separate, right? It is easier. And if you want to have then the 2 of them together, define a third one, okay, to say the set of all of those things.
Okay.
Yeah. Any more questions?
So in this example here on line 13, would you call that one gradients and then define a trainable predictor with gradients, both of them?
Yeah, so like basically I could say, actually this is a predictor, this predictor with, this is actually a gradients thing that is not a predictor, and then you have a trainable, which is something that you can retrain. So you can basically give parameters. So then you could go into like, oh, I want a predictor with gradients, which is gonna be a predictor with gradients.
Yeah.
Right, like, this is how I would structure it. It's more like composition. You're gonna start with the smallest interfaces that make sense, and then see how they compose when you need them. This, yeah.
Yes. So this is the problem that I deal with a lot. When do you think it's okay to return an interface, especially from an interface? Like in the stack example you had.
Oh, when an interface wants to return an interface. I mean, context is the right example, right? Like if you're doing this because you're hiding information, then basically what you're actually doing is using that interface as the type. So when you do background, it gives you context, right? It is actually an empty context, but you don't care. When you do with timeout, it gives you a different context, but you don't really care. So in those cases, when you're just hiding implementation, it makes sense that everything is going to be an interface. Like even the new or anything, that all of those things are interfaces. If you're not trying to hide implementation, then it is better to return concrete data. Yeah.
What about pointers to interfaces?
Pointer interfaces are evil.
That's all I remember from the documentation is
yes,
basically
do not do this.
Is there any
the only reason to have a pointer to an interface is when you want to change the value it holds. That is the only case. And I've never seen that in real life.
You like shuffle out the actual.
Yeah, basically like imagine that, so if you have, go back here to the playground. Imagine that you have, so wait, my brain just went away.
Isn't that what container heat does though? Exactly, is pointer to interface?
Yeah, actually so that's a good example. Container, I think that's where it does it, right? No, it doesn't even do it here. No, but imagine that it's basically like when would you have a pointer to a slice? It is exactly the same reason.
Okay.
When you want to change not the thing backed by the interface or the slice, but when you want to change the interface itself. Okay. Right? Otherwise you cannot do it. So the example that I was gonna write is basically like func whatever. Yeah. But you're getting a fun dot, let's say a fun dot stringer, right? Stringer. And you want to say actually s equals something that satisfies stringer. Okay, io dot reader. So it's a new bytes dot buffer, right? If I want to do this and I do foo of so var s equals another bytes dot buffer. No, strings dot builder. Because that also works. And you can do this. And then I'm going to print, so printf the type of S, and then do that again here, but type it correctly. Printf and printf. All right, so if you do this, nothing works because you need to import. That should be by default. Reader and argument foo. Okay, so you actually need to do.
That's actually past that, right?
Neo strings builder. I think that works. No, reader and argument foo.
Don't you have to
a builder is not a reader?
Is it a writer?
Oh, no, it's a writer.
It's a writer.
Writer.
Okay, fixed. Okay, so here what this is doing, right, is telling me that this is a strings builder, and after saying, oh, I'm changing this, what did I do? That was a compiler error. Wow. I don't understand how. But yeah, this is a pointer to strings builder, and after changing it, it's still a pointer to strings builder. This is normally the behavior you want. Right. If that was not the behavior you wanted, you could do something like, actually, I'm gonna get a pointer to this, and then change it, and do this, and that is really ugly. Yeah. Because also, I think that you're gonna need to pass something like this, and I'm not even sure that works. Because that pointer to an interface, oh no, sorry, this. And it's a pointer to an interface, so I think that you need to do.
I think this answers it, which is
S.
Don't. Don't is a good answer.
Really cool.
Okay, I was like.
I want to make it compile. There you go.
All right.
So yeah, don't do that.
Unless you really have some real.
The only reason why you would want to do it is because you want to change the variable, like the interface itself, not what it contains, which is super rare. Rather than doing that, just receive a writer and return a writer. This is what you're going to be seeing in general, right? Like what you're doing is then just, and actually that's how you append things to a slice, right? Like it's exactly the same idea.
Another question. This brings up.
Easier, please.
Well, yeah, no. This is more of a question about preferences. So I see you doing a lot of, I almost never use var, like ever. I use colon equals basically exclusively. Is there?
I use var for two reasons. One is when I want to specify the type, like in here.
Right.
The other reason is when I'm declaring a 0 value of something that is not initialized and I'm going to initialize it later. So for instance, if I'm writing like if I'm using a buffer, I'm going to do a new bytes of buffer. But when I'm reading something, probably I'm going to do like var data struct whatever, and then read from it. So by doing this, right, like the idea is that I'm saying this is the 0 value, and I will use it later, somehow initializing it.
Okay.
It's a totally personal thing.
Yeah, I figured about it.
It's completely up to you. Yeah. Any more questions?
All right, let's give another round of applause. You're welcome to stick around and talk. I don't know if Francesca's sticking around, but
yeah, I'm gonna stay around. Okay. By the way, if you wanna check it out, it is on speakerdev.com/Campoy. I have all of my slides, and this is basically the same as Will contract replacing the page, and at the same time.
we'll link to that in the GitHub repo for you to
Yeah, one day. We'll get around to that.
Post it on the
Mariah will
Instagram.
do it tomorrow.
I'll post it on Instagram.
Yes.
It'll be on Instagram only.
That one follower.